Good morning. I would like to discuss a simple problem on Fourier transforms. This is our function f of x equal to 1 minus x square for mod x less than or equal to 1 and 0 otherwise. We have to prove that f of x equal to 4 by pi into 0 to infinity sin omega minus omega cos omega by omega cube into cos omega x d omega. Also, we want to deduce that integral 0 to infinity sin omega minus omega cos omega by omega cube into cos omega by 2 d omega equal to 3 pi by 16. First we have to write the equation f of omega equal to 1 by root of 2 pi into integral minus infinity to infinity f of x into e raised to minus I omega x dx. But since it is an even function, we can write that f of omega equal to root of 2 by pi into 0 to infinity f of x into cos omega x dx. We have to substitute the value of f of x, so we can write that is equal to root of 2 by pi into integral 0 to 1 minus x square into cos omega x dx. Upon integration, we can write that equal to root of 2 by pi into 1 minus into sin omega x by omega minus 2x into cos omega by omega square plus minus 2 into minus sin omega x by omega cube from x equal to 0 to x equal to 1. Upon solving this, we can now on simplification we will get like this is equal to 2 into root of 2 by pi sin omega minus omega cos omega by omega cube. So now we have to find the inverse Fourier transform. Since it is an even function, inverse Fourier transform is equal to inverse cosine transform. So f of x is equal to root of 2 by pi into 0 to infinity f of omega into cos omega x d omega. Now we can substitute the value of f of omega by 0 to infinity 2 into root of 2 by pi sin omega minus omega cos omega by omega cube into cos omega x d omega, which is equal to 4 by pi integral 0 to infinity sin omega cos omega cube into cos omega x d omega. So this was the second. From this we can write integral 0 to infinity sin omega minus omega cos omega by omega cube into cos omega I is equal to pi by 4 into f of x. Substituting the values of pi by f of x, we can write it is equal to 4 into 1 minus x square for 1 and 0 otherwise. For finding the for deducing the third equation, we can give x equal to 1 by 2. So integral 0 to infinity sin omega minus omega cos omega by 2 d omega is equal to pi by 4 into 1 minus 1 by 4. It is equal to 3 pi by 16. So this is what we wanted to prove, and hence